by very nature of what it's called, the fundamental theorem of calculus. It's an important theorem. It's the fundamental one, and it's one that you should remember. And it goes a little bit like this. If you've got the derivative with respect to x of some function of x, and we'll use capital F of x as equal to f of x. So when you differentiate this function, you get this function. Then the integral between a and b of this function with respect to x is equal to f of b minus f of a, where this is capital. So that's the fundamental theorem of calculus. If the derivative of this function, these are two different functions, but they are related. So when you differentiate capital F of x, you get lowercase f of x. Then when you want to integrate lowercase, you get this function and substitute in the b value, and then you get this function here, capital F of x, and you substitute in the a value. You always do the top one first, minus the second one. Graphically, you've got f of x, and this here between a and b. It's the same old story here, that this here will be this area there. You can see why sometimes they called f of x the antiderivative of lowercase f of x. Antiderivative. To actually find capital F of x, you've got to find what you're looking for, a function that when you define the derivative of this function, you're going to get that. That's what this is saying, that when you find the derivative of capital F of x, you get lowercase f of x. So when you, f of x is called the antiderivative. When you differentiate f of x, you've got to get lowercase f of x. So when you're trying to integrate something, you've got to say, what function have I differentiated to get this function? And that's why they call it the antiderivative. So that's the fundamental theorem of calculus. When we integrate, you've actually got to ask yourself, what function have I differentiated to get this? And that will give you what value, what function you put here, and then you can substitute in values b and a, which we're going to come back and do more examples of.